Nice. Bismillah ar-Rahman ar-Rahim. So, let's start by first review on data types in Java. Data in Java is one of two types. Either it's primitive, which means the data itself, simple data itself, or reference to an object, which means which includes a composite data. The primitive can be either Boolean, which means true or false, 0 or 1, as we said earlier, or integral, or floating point, which is a way to say fraction. And the reference is everything else. For the primitive data, we have data of type 1 or 2 or 4 or 8 bytes. Boolean by data type is not defined across Java, so it's implementation details. That's why I didn't put it in either any of these sizes. So this is done on purpose. For integer, we have data types that takes 1 byte. It's called byte. 2 bytes called short. 4 bytes called int. 8 bytes called long. And we have I, and we have floating points of size 4 bytes called float and 8 byte called double precision. Float stands for floating point and double for double precision. And we have another type called character, which is char, stands for character, and this is the only unsigned type. It holds the Unicode value, Unicode code of the symbol which we refer to. And we mentioned some different flavors of that type. So the int contains the value in 4 bytes. The float has the data encoded some other different way in 4 bytes. The character has only 2 bytes, having holding the Unicode number of the symbol. The string is an object if the string contains the single character 5. So its length is 1. A string contains 2 fields, the pointer to the data and the length. And today topic is about string. We'll talk about strings in detail today. Another string can be longer and can intersect with one other string. So we may have another string contains 555, starting from the same point, but with more length. This is a review on the last slide or slide before last time. It's very important, so I'm repeating it. I need to confirm that all Java operations are performed on equivalent size operands of at least 4 bytes size. Equivalent and size and type, at least 4 byte size. So both operands must be at least 4 bytes and must both be of the same type, which means they belong to the same column and the same row. If not, there promotion occurs according to the arrow direction from up to down and from left to right. So from 1 to 2 to 4 to 8 bytes, and from float, from unsigned to signed, and from signed to floating point. The opposite is called the cast. If you go from float to integer and from signed to unsigned and from bigger to smaller. So operation containing both operands int and int produces int. Short and int produces int because there must be at least in 4 bytes in this area. Byte and int produces at least int, same idea as short and int. The byte is promoted to int, and both become int, and produce the output will be int. Short plus short, they are although they are both of the same type and size and type, but both of them are smaller than int, than 4 bytes, so they are promoted to int. Byte and long, what will that produce?
I believe by and long, that is, it stays as long, or does it become?
Exactly, yes,
Oh,
long.
nice.
So the byte is promoted to long to match the other one, and they are both operated upon as longs. Float plus float, here they are both of at least 4 bytes and both of the same type, so the output is float. Float and int, both of the same size but not of the same type, so the int will be promoted to float, and we perform it as float plus float, producing float. Float plus double, both belong to the same column but not to the same row. So the float will be promoted to double. So it will be double plus double, which is double. Okay.
Right.
Float plus long is the float,
Is
and long
is double
is double. Yes. Why?
because they're both 4 bytes, and it has to be because they're not the same type. It has to become the other kind. They have to be one type.
Right. So the 4 will be promoted to 8. It will, and the integer will be promoted to float. So it will end up being both doubles. The float will be double and the long will be double. It will be double plus double. Okay,
Right. Yeah.
nice. I think this line should have been earlier. Okay, nice. That was the end of last time lecture. Starting with today lecture. Uh, which, which, where is the screen? I need to screen record again. No screen, share, hold the screen, share, and hide. Okay, today's topic is about string class. Okay, string is one of the most used and the most important classes. It's available in almost all programming languages. Okay, and a string in Java is an object. It's not a primitive type, which means it has more than uh, one thing to contain. It's actually a complex uh, data type. It has uh, two types of data. Length, it can be 0 or more. Of course, it cannot be something minus, but it can be 0, and it can be 1 or 2 or whatever number, up to the size of integer. And it has a data type that we don't see in Java, which is in C++ on C, called a pointer, which points to where the data uh, is located in the memory. So it owns the data, and it has a length. Okay. Also, as a class, it has behavior or methods, which is something we will talk about later when we discuss the object-oriented programming, and we touch it by the end of this lecture, inshallah, or this topic, inshallah. String class is present in the java.lang package, and which means we don't need to import it because all classes in the package java.lang are imported by default. You remember that?
Um,
I assume you remember that.
yes.
Okay. String class inherits from object directly, so it doesn't have multiple inheritance or long hierarchy. And in addition to being derived from class, which we'll discuss later, it has some features which we define as interfaces. It's serializable, it's a character sequence, it's comparable, it's constable, okay, and it has the constant description. Just deal with the string class now as it is. Um, these interfaces are just common with other things. So when we say something is comparable, it means it can be ordered from small to big, or the opposite. So we can order the names alphabetically. If we say it's character sequence, it means we can reach each character by its location or from the start to the end. Serializable means we can send it over the wires over the internet or whatever, etc. Okay, now how does the string object look like? This is part of the memory, contains whatever data. The memory is actually sequential. For simplicity here, I show every two locations as one because the character in Java is 2 bytes, as we remember. There are some characters located somewheres all over the memory, and the object describes what is where and what belongs to what. So for string class is an object that has two fields. I want the laser. Okay, so this is a string object. It contains two things. A pointer refers to the buffer of the start of the string, and length. I'll tell you later why this length is important. So here I have an object which says I own the data from starting from this point with the length of 18 characters. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 17 or 18. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 no 18 I just miscounted. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. So this thing is the content of this object. It has the characters which make the name Muhammad al-Husay. It's my son. Okay.
Right.
Having this object, we declare that we own the memory from here until 18 for, the length of 18 characters. So from here to here. The computer is very, very, very slow, and let's free some memory. Give me a second, I need to free some memory. Let's close this. This should be enough. Okay. Much better, huh? Much better. Okay. Another object starts from here and owns the length of 13 characters. So it contains AMR space ALHOSSARY. This is Amr al-Husari. This is my name. A third object can start from here with a length 11. REEM space SHERIF. Reem Sharif. This is one of your colleagues, senior colleagues, who is actually now joining the university. She was in the robotics last year. Okay. So now we have three objects that own the memory all over the place. Okay. And I intended to show you that SHER and I at the second line, because the lines in memory don't mean much. Everything in the memory is linear. Okay, so this is the object. Now what I'm going to tell is very important. This is the object. This is the data the object contains. Okay, this is the variable which refers to the object. So I have a variable called name1. So name1 refers to this object which contains the data Muhammad al-Husari. Name2 refers to this object which contains the data Amr al-Husari. Variable 3 refers to the data which contains Reem Sharif. Okay, I have three variables. Every variable refers to an object, and the object contains data. You have to differentiate between variable, object, and data. If we have another variable, another object, sorry, that has length 0, it may not be holding any memory because the length is 0. I don't show it here, but we can consider that. Okay, so this is the variable, this is the object, this is the memory allocated buffer. Give me a second, please. Muhammad is asking about something. نعم. حاجة في الكورس؟ قول صوت عالي. ايه؟ ايوه. طيب, Muhammad is asking, when the length is 0, does it mean that there will not be a pointer, or there will be a pointer but nothing is referring to? It's either none of them. There is a pointer. For safety, the pointer refers to a special address which is 0, referred to as null. This is something in C or assembly. So it's a null pointer. However, in Java, we don't mainly care about being allocated to null, because we look first at the length. After looking at, if the length is 0, we don't care about what value is in the pointer. The pointer refers to, okay, but note that when the object is created, its value is loaded using the class loader, which sets the value to 0 if we don't set it, which means null. Does it make sense? Thank you. Forget about him. His question is a little odd. What we care about is that if the length is zero, an empty string, we don't care about whatever is in the uh, buffer pointer or data pointer. Okay. Now I want you to understand the difference between a variable, an object, and the data. It is very important because a variable can refer to an object today and another object tomorrow and a third object after half an hour. But the object itself is the same object, it doesn't change. And when this object is referring to this area of the memory, this area doesn't change. How does this come? Suppose we have a name, another variable called name4. Name4 can refer to name3. So now name4 and name3 refer to the same object, which means the same thing, which means refer to Rim Sharif. Another variable called the current user may refer to now to name1, which is Muhammad al-Husari. After 5 minutes, we'll reassign it to this object, which is Muhammad al-Husari. So the variable can change, but the object and its data, at least the object now, the object does not change, neither in location nor in length. Is that clear?
Right.
Fine. Let's make this very obvious. Here, variable here, object, and here data. Okay?
Right.
Okay. Now, another piece of information about the string. String is called, oh, I need to delete this. Okay. A string is an immutable class. Mutation means to change. Not really exact change, but modify. Yeah, anyway. Something which is mutable means it can be changed. Something is immutable means it cannot be changed. Never changes. Give me a second, please. Give me a second, please. Okay. So a string is immutable, which means its content never change. So from the onset of creation of a string till the end of the life of this object, its content never change. This is in contrast to other classes like or languages like C++. The string in C++ is immutable. The string in Python is mutable, just like Java. So every class implements the string in a different way. Consequently, if we do any change or modification in the string class, a new string object is created for every change or modification. Okay?
Right. Got it.
Nice. This allows us, or allows the implementers of the Java to make use of a very interesting feature. If I have two strings that share that share the same content, they can actually share the same memory allocation, because we are not afraid that modifying one string will corrupt the other one. Because any modification will make a new copy. It will not be affecting the original one. Let's see how this looks like. This slide already we described it earlier. Okay. Same slide here. عمرو الحصري, ريم شريف, محمد الحصري. I have object called for عمرو الحصري for yeah. If I have an object for الحصري with the length 9, الحصري only. neither عمرو nor محمد. الحصري only. Starting from here for the length of 9 characters. And another object الحصري starting from here for the same length with equal value of the content. We can simply name 1 refers to here, name 2 refers to there. We can simply make the two objects refer to the same area of the memory, or even remove one of them and okay. Anyway, these cases are equal, right?
Looks to be.
Both cases are equal. We can even remove the whole object and we make name2 refer to the same object as name1, as simple as this, which will make the memory utilization more efficient. Okay. Next topic in a string is how the equal operator works on the string object. We know that equal operator means equals. We remember that from the last lecture, right?
Yes.
Okay. The equal operator, when we apply to string, it compares the address of the object, not the data. So if I have name1 referring to this object and name2 referring to that object, sorry, yes, referring to that object, although the data is equivalent, they are not the same object. Okay?
Right. Got it.
Even if they refer to the same data, they are still two different objects.
Right.
Okay?
Got it.
Before we move on, let's see how this looks on the compiler. We'll take this code and run it. I think I have it already. String test class. Yes, I have it already. Control X and Control V. Yes. Okay. I have I have string, indication of a variable of type string. S1 equals ABC, capital ABC. So everything is capital. We don't want to make confusion by capital and small. But string S1 equals ABC. String S2 equals ABC. Okay?
Right. So it's the
String
same.
S3 is a third variable equals S1. Okay?
Right, right.
Is a new variable. String S4 equals new string object. New string what?
A new string object.
Not variable.
Huh? Oh, right. Yeah, yeah.
String S5 is a new string object containing a similar value. Everything containing ABC. Everything containing ABC, okay?
Right.
String S5 is a new variable referring to a new object equals to S1. Okay?
Right, right.
Let's print the output, see the output of using the operator equal. Actually, you see the yellow lines here. Uh, the IDE is warning me that using equal is not a good idea. Let's compile. So equal. Now let's test. S1 equals S2 is either true or false. S1 equal S3 true or false. S1 equal S4 true or false. S4 equals S5 true or false. S5 equals S6 true or false. S1 equals S6 true or false. Okay.
Right.
Okay. The rest of this is we can hide later. We can do it later. And we will come to that later.
Right. Okay.
Okay.
Mm-hmm.
Let's run and see. Now, S1 is a new object. No, I didn't say a new object. Is this string literal? S2 is the same string literal. S3 is a new variable referring to the same with the same with equal value of the same object. S4, 5, and 6 are three new objects. Okay,
Mm-hmm.
nice. And run. Someone says something in the chat. I have to drop by Professor Amr. I will comment. Okay. Okay. See you inshallah later. Salam alaikum. Okay. S1 equals SS2 is true. S1 equals SS3 is true. 1 and 2 refer to the same literal. So when we create them, they are assigned the same object. Two variables referring to the same object. Okay?
Right.
1 and 3, true, because we literally say that this variable equals the same variable, this variable. Okay?
Yeah, makes sense.
Okay. 4, 5, and 6 are all new objects. So S1 equals S4, false. S4 equals S5, false. S5 equal S6, false. S6 equal X, S1 is also false. Although all of the six string variables refer to a comparable data, even whether they are the same or comparable, whether they are the same location in the memory or not, but they are comparable.
Right.
Okay?
Yeah.
So how can we evaluate the value of the string?
The value.
Here comes the use of this function called equals.
Right.
The creators of Java, Gosling and his friends, didn't let us very confused. They gave us a function in the Java, sorry, in the string class called equals, which evaluates the components, the content of one object versus another passed in object and returns either true or false. Okay,
Right. Right.
let's see what is here. Remove all of this. And let's run. Nice. We see that all of them, when we use equals, the value is
That means it's
what?
all true.
All of them are true.
Yeah. Ah,
Okay.
right.
So make to take care, we rarely care about the variable itself. We mainly, not only one mainly, and not all one, mainly, always, often, mainly care about the content.
Ah, yeah.
Okay.
Right.
So comparing the content is done using equals. Comparing the address of the object is done using equal operator. Done? Fine?
Yeah. Yeah. I got it.
Okay. Let's rephrase that in a presentable way. String literals are compacted in the memory at the startup. So I'm talking about string literals. So if you give us a literal, which is anything between two bracket to double, a pair of double quotes, uh, any string literals can share some of its content with others. So Amr al-Husari can share some content with Amr, or al-Husari, or Husa, or R space al-Hus, or whatever. It can share. Shall we use the equals operator to compare string contents? The answer is
Um. Yeah.
no, unless you really know what you are doing. Sometimes we need it. That's why they keep this behavior, but usually we don't know it, don't need it. We rarely need it, and we should use it only when we know that we need that. So no, unless you know what you are doing. Okay?
Right. Makes sense.
Okay. Now, before I wrap up, I want to tell about two things. String class has several methods or functions to do some behavior as we need. This is a list of the most important methods of the string function. We talked about equals. What does it do?
It makes the statement or the strands equal to each other, or
The string contents.
yeah, the contents. Yes.
Okay. There is another one called equals ignore case. What do you expect it does?
I'm not quite sure.
With the case, we refer to uppercase and lowercase, which mean
Oh,
capital and small.
oh yeah, that makes sense.
So it simply compares the content of the string of the two strings, ignoring the difference of the case of letters between small and capital.
Right.
There is a function called length, which returns the length of the string, a value from that's zero or more. So what do you think is empty does?
It makes it 0 or just
Yeah,
empty.
tells me or returns a boolean which tells me whether the length is zero, so the string is empty or not.
Right.
Okay, nice.
Hmm. Okay.
We have substring taking a beginning index and end index. This can be used to extract a part of the string from some place to some place. So my name is Amr Ali Al-Husari. So I give you the index of 4 and I don't remember. I think 8 or something, or no, yeah, almost 8 or something like that. 9. It will extract Ali.
Uh, I
But
see.
if I give it 0 and 4, 0 and 3, it will give me Amr only. Substring.
Right.
Okay.
Hmm.
We have car at, get cars. We have index of. We have compare to, and we have compare to ignore case. Like like what we have equals and equals ignore case. Okay.
Hmm. Right.
So these are the most important methods of the string class. We have to uppercase and to lowercase, which converts from small to capital, from capital to small. If something is already small and I call to lowercase, it does nothing.
Right.
And as we said earlier, any modification of the string produces a
Say again. The audio glitched.
any modification in a string object produces
It produced.
a what?
Uh, I don't know. I forget the name for it. It's on the tip of my tongue. It's the. I want to say class, but that doesn't sound right. No, it's not that.
Any string, what is it? A new object is created for every change or modification. So any change produces
String.
a
New string. New string.
yes, a new string object.
Oh yeah,
Okay.
yeah. Okay.
Okay. Uh, your homework, before the homework is another slide. We said that the string is immutable character sequence.
Right.
There are other mutable character sequence classes like string builder and string buffer, and you can Google the difference between them yourself later.
Right.
Okay, so
Okay.
so the string is a mature object. The string builder is when we are still building a string.
Right.
This is mutable.
Hmm.
Okay, now your homework will be to read the Java documentation. It's called the Java doc of string class from this link.
Okay.
So when you read the
So,
documentation, I know this is your first time to read the documentation. I care mainly about two things. The description paragraph. Let's see how the documentation look like. How can I escape? Yes, here. Okay. This is the documentation of the string class for Java SE 21, Java JDK 2021. This is documentation. I know this is the first time, your first time to read the documentation, you or anyone who will see the video.
right.
Here we have the module which contains the class and the package. We know it belongs to Java Lang. The class name. And its inheritance series. So string inherits directly from object. When someone sneezes and say alhamdulillah, you have to say alhamdulillah.
Right. Yeah. Okay.
يديكم الله سبحانه. And you have to reply يديكم الله سبحانه.
Yes. Okay.
So this is all language string. In short, we say string. These are all implemented interfaces. As I said, they are character sequence as just a character sequence like the string builder and string buffer we mentioned earlier. Comparable means it gets compared. It can be ordered, whatever. And by the way, as we mentioned, comparable. We mentioned we have compare to and compare to in your case. That's why it's comparable. Okay. Then we have a very condensed description about the string class, how it is used. Okay. Limitation note. Where it is described if you want. When it was introduced to Java, so string is used in Java since Java 1.0, the first version of Java. Some classes are introduced later. Okay. And C also is very interesting section which tells you about more related functions or classes that you may be interested in knowing about uh, when you know about string. So if you know about string, then it's nice to look also at string buffer and string builder. Okay.
Okay.
Then we have a field, all of the fields, forget about that. Constructors, we'll talk about that later, very later. And method summary.
Yeah.
Methods can be there are static methods, instant methods, concrete methods, deprecate methods that are no longer used, like get bytes. This is all bytes are all methods. So this contains all of these. Okay.
Okay.
Now for every method, there is a one-line description. Now, if you have a method called char8, which takes parameter index, it returns the character value at the specified index. So if I send, so let's say equals. We have seen equals already, right? A B C D equals compares the string to the specified object, an object. Okay. If we click on equals, we see a detailed description.
Mm.
Public Boolean equals with parameters object and an object compares the string to the specified object. The result is true if and only if the argument is not null and is a string object that represents the same sequence of characters as the object. For finer grained string comparisons, refer to later. Forget about this now. And this function equals is actually defined somewhere else in the class object, and it takes, these are the parameters which it take. Here, this only takes only one parameter called an object, is the object to compare to a string against, and returns true if the given object represents a string equivalent to this string, false otherwise, and C also. Okay.
Right.
Now, this is interesting function which I didn't know about, actually. This called equals, which compares string to a string. There's another function called content equals. It takes a string buffer. So if you have a string and you need to compare it to an object that is not a string, you should not use equals, because equals work on two string objects. But content equals does the same, but it accepts a string buffer rather than a string. Compare the string to the specified string buffer. The result is true if and only if the string represents the same character sequence of characters as a specified string buffer. This method synchronizes on the string buffer. For final grained comparison, refer to later. Parameters SB, which is a string buffer, to compare the string against, and returns true if the string represents the same sequence of characters as the specified string buffer. False otherwise. Since Java 1.4. Before Java 1.4, there was nothing called string buffer. You see? Now we have content equals taking string buffer, content equals taking character sequence, the same thing started since Java 1.5. And we have equals ignore case. So if you know the first paragraph of the description, or maybe even the first line of the description. Wait. Equals. If you know this line, this might be enough, and you don't need to read the rest of the paragraph. If this line is not enough, then you can go to the description to read this paragraph, which should be enough. If not enough, you will find more details below. Overrides, parameters, returns, see also, etc., etc., etc.
See.
Okay.
Okay. Sounds good.
So this is how we usually read the documentation. The documentation is ordered in a way that makes two ways that makes related things can help augment understanding each other. If you understand equals, then you understand and read one line about equal ignore case, then you have already read equals ignore case.
Right.
If you know equals and you read one line about content equals, then you don't need to read about content equals, which has already two copies, one for character sequence and one for string builder.
Right.
Okay?
Okay.
The same applies to everything in this string class. Although the file is very big, but the contents can be summarized into this table.
Right. Thank you, brother.
Welcome. Now, your homework is to read the Java doc of a string class from the documentation. I will send the presentation, inshallah, today. And I care about the description paragraph and the most important methods in the last slide. I mean, this slide.
Right.
If you can read all of the method summary table, it would be better. And don't read the implementation note.
Okay.
Don't read the implementation note, like here. Don't read it. I said do not.
Right. I won't. I will not read it.
Okay, if you read it, you will feel that, oh, Java is so hard. I don't understand anything. It's very complicated. I'm restricting a lot of things. Don't read implementation notes. Okay?
Right, right.
This is needed for those who will build their own Java,
Right.
not those who are using Java.
Yeah. I got it.
Okay, now see, and also don't read this.
Right.
Don't read invitation note. Let me modify it and add. Okay,
Okay.
nice. So this should be the end of this lecture.
Mm.
Is small and concise, but it's important. The rest will be on your own.
Thank you, Brother Amr.
Welcome. See you, inshallah, next week.
Inshallah. Assalamu alaikum.
Alaikum salam wa rahmatullah. Stop share and end.